Okay, last time we left off with hyperbola 7.2. So we talked about the graph centered at 0, 0, and really this makes our life a little easier when we can center at 0, 0, because then we have to just think about going up A or over A or going up B and over B, depending on if it is a transverse x-axis or a transverse y-axis. So depending on if the function opens up and down or if it opens left or right. And that all depends on the term that has the negative in front of it, right? It's a transverse x-axis, meaning it's opening left or right if the y term is negative in front of it. It's a transverse y-axis, meaning opening up or down if the x has the negative in front of it, right? And then we had the corresponding a and b given. We can calculate c by taking a squared plus b squared is c squared, right? The asymptotes, pretty straightforward when it's at 0, 0. It's either a over b or b over a, depending on if I go up a or if I go up b, right? I go to left a or I go to left b. It gets a little more interesting on the equation of the asymptotes when we shift. When we shift it, to find the equation of the asymptote, we actually have to apply point-slope equation of the line. So the point is the center, and the slope is still going to be a over b or b over a. The one extra step is just solving those two linear expressions for y, and that gives you the equation of the asymptote. The slope's always going to be plus or minus, right? Rise over run. So you always come up with two asymptotes. We finished the lecture with this example, and the example centered at 1, 4. And it turned out the transverse axis was the y-axis, meaning the x had the negative in front of it. So we see here that this x term, whatever the x squared was negative, so it means it opens up or down. So it turns out all my x values here are -1. So that's kind of just a nice quick check that I'm only changing y. So here, y goes up 5 units. So if I go up 5 units from 4, I'm 9. If I go down 5 units from 4, I'm -1. So that gives me my vertex. You guys remember doing this? Slept a couple nights before then. So let's look at this example. We have to convert it to standard form. So just like what we did before, one of the terms are going to be negative, though. So we have to be very careful when we pull out that negative term. So converting this equation to standard form, I'm taking the x values and the y values. Turns out the y values here are negative, right? So this is going to be transverse x-axis, meaning opening left or right, if I needed to graph it. But right now, I just want to put it in standard form. So I would write factor out of 11. I have x squared plus 6x minus 2. I have to be very careful. If I factor out a -2, this is actually y squared plus 2y. Do you guys see that? -2 times a +2 will give me a -4. So that's probably another very common mistake students make when they're factoring out that one term that's negative. You have to also factor out the negative. So you want to be careful. And one way to do that is just check yourself really quick. -2 times y squared is -2y squared. -2 times 2y minus 4y. Does everyone have the notes from the other day? I have one extra copy if you need them. So now it plays the game of completing the square again. On some of these, you're going to deal with fractions. That's okay. It's just another shift being a fraction. So don't get too caught up on the fraction. And it might not be in this section. It'll be in the next section. We deal with some fractions. So what do I need to do to complete the square here? What do I add I'd add 6 over 2 squared, which is 3 squared. So I add 9. If I add 9 to the left-hand side, I'm really adding 9 times 11. So if I add that to the left-hand side, I also have to add that to the right-hand side, plus 99. You guys remember doing this in the previous section? What do I need to add here for a perfect square? 1, right? I have 2 over 2 squared, which is 1 squared, which is 1. But I added 1 to the left-hand side. I'm really adding 1 times minus 2. So I need to add minus 2. Another common mistake students will do, they forget once I add on one side, I have to add to the other side. Okay. So breaking this down, I have 11. What is this perfect square? X plus 3 squared, right? Minus 2. What's this perfect square? Well, y plus 1, right? Squared equals minus 75 plus 99 minus 2. 22. And then you guys remember the very last step to get it into standard form? Divide all terms by 22, and I get x plus 3 quantity squared over 2 minus y plus 1 quantity squared over 11, and that equals 1. I don't know where the 2 came from. On an exam, this is where I'd ask you to do. Once you get it in standard form, you can stop. From standard form, though, you know the transverse axis is the x-axis. You know the vertex, well, you know the center is minus 3, minus 1. So you can tell a lot from it from standard form, but the whole goal would be to get it into standard form. There's a lot to do to get it to standard form on an exam. I wouldn't then expect you to graph it, because if you form right, you're not going to have the graph right. Any questions? I want you guys to work on the second one there, putting this one in standard form. It's very similar. Write the equation in standard form. On the exam, you might have to classify it. Is it an ellipse? Is it a hyperbola? Or is it a parabola? So it's knowing one of the terms negatives makes it a hyperbola. If there's no negative terms, then it turns out to be an ellipse. You have the center, you have the major axis, the minor axis, vertices, focus points, things like that. Be a little careful here. This is positive. So if you were to distribute this minus 7, it's a minus. So last time we talked about what it means to be a perfect square. And if the coefficient is 1 in front of the x squared and y squared, and we made it that way because we pulled out the greater than 7, we take b over 2 squared, and that's what you add. Yeah. Oh, these two. They're all signing it. Okay. So last time we talked about if I have x squared plus bx. So here, what we put in here is b over 2 quantity squared, and then that makes b plus b over 2 quantity squared. So that's how we simplify it. So in this case, if I have x squared plus 10x, I need to add something here. Whatever I put in this box, no, maybe not the box, whatever I put b over 2, let's put the squared up here. Then whatever's in this box, I drop it down to that. So this would be 10 over 2 quantity squared, right? Which would be 5 squared. So if this was 5 squared, which is 25, I would have x plus 5 quantity squared. It's a perfect square, so it's x plus 5 times x plus 5. So here I add 25, and I have to be very careful when I'm multiplying, because there's an equal sign over here that I also have to add to. Yeah. So if you add the 25 here, really you're adding 75. 25 times 3. So you have to add 75 to this side. And the whole point of adding 25 here is so you can write x squared plus 10x plus 25 as x plus 5 quantity squared. That's the perfect square, so that when you jump down here, you can make it x plus 5 squared. And you do the same thing here, where we have a minus 8. All right, so let's go over this one. The first step I do, and most of you had gotten to writing this, setting this up correctly. So the setup's going to be 3x squared, right, plus 10x minus 7y squared. And then here, it's very important that you write minus 8y. Because if I distribute this, I get a positive 56. If I would have left it as positive 8y when I distributed, I would have got a negative. So I pull out that negative, meaning I switch the sign after the parentheses. So here I have a positive y squared, so that means I'm going to have a minus 8y. Okay, see that? So setting it up, 10 over 2 quantity squared would be 5 squared, so I add 25 to the left-hand side, but really I'm adding 75 because I'm adding 25 3 times. Here I take minus 8 over 2 quantity squared. That gives me minus 4 quantity squared. So I'm adding 16 times minus 7. So I add 16 times minus 7, which is minus 112. Does anyone have any questions on that step? So here it's setting it up. So I have 3x plus 5 quantity squared minus 7. Here is x minus 4 quantity squared, right? And that is going to equal 21. 58 plus 75 minus 112. Any questions at this point? Divide through by 21. I get x plus 5 quantity squared over 7 minus y minus 4 quantity squared over 3 equals 1. So then I can answer my questions. It's going to be transverse x-axis, meaning it's going to open left or right. The center is at minus 5, positive 4. right? So then I can talk about the vertex by going a square root of 7 or a square root of 3. So these numbers are going to be a little funky, but this point was to get it into standard form. Once you're in standard form, you can graph it. Any questions on that? The next part is going to be given information about a graph, plug in the relevant stuff and get the formula. So recall the formula is x minus h squared over a, see, plus or minus, y minus k squared over b equals 1. Depending on what a and b is, also as well, right? Depending if it's going to open to the x, open transverse x or transverse y. So we have to kind of put in the interesting points here. So I know the vertices are at -4, 1, 2, 3, 4, 0, and 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Vertices tells me this is transverse x, right? Vertices, transverse x. So it's going to open left and right. The y didn't change. This is -4, 0, and this is 8, 0. So what is the center? Right? So this would be 12 units long. So half of that's 6. So 6 units from the right of this dot or 6 units to the left of this dot would be 2, 0. Right? Which one's negative? Which term's negative? The y term, right? Because it's transverse. So I can start here by saying x minus 2 squared minus y minus 0 squared equals 1. Now I need to come up with a and b. This distance is what? Yeah, and you simplify it that way. But I just want to show that the y component is 0 here because it might not always be that way. But yeah, you would write just y squared. By definition, this is a. What is a? 6. Yeah, so this would be 6 squared. Oops, sorry about that. These should have squares, a squared, b squared. So I need one more point to find, and that gives it to us here. The focus is at -8, 0, and at 12, 0. So right, -4, 5, 6, 7, 8, and 8, 9, 10, 11, 12. So this distance from here to here is C, which is, I heard someone say it, which is 10, right? C is 10, so I use the formula C squared is A squared plus B squared. So 10 squared is 6 squared plus B squared. So 100 equals 36 plus B squared. 64 is B squared, so this would be 8 squared. Huh? So simplifying this, I have x minus 2 quantity squared over 36 minus y squared over 64 equals 1. Okay, see that? So there will be some, here's the general formula, graph it. Here's some information about the graph, find the general formula. So you should be comfortable in finding A, finding C, finding the corresponding B, finding the center from the vertex, finding which one's positive, which one's negative, and then knowing that general formula and plugging it in. So the last thing we're going to talk about is this constant value E, which tells you how smushed is our hyperbola. Not talk today. The branches either open wider or kind of open smushed together. So this value E here, there's not a lot of application. Know that it's the ratio C over A, just like it was in the ellipse. And I don't have too many examples. I'm going to pull up Alex, and it might ask you to calculate E. So let's pull up Alex. Throw on my, actually I think it's memorized. C-A-N-I-N. Oops. I'm going to go to Students View. So apparently, so this is 7.2. So the first example, graph the hyperbola given the equation. So which is our transverse axis? The Y, right? It's opening up or down. So if I come in here, I think I have to rotate this. Let's see if I can do it. Okay, yeah. So this is just the general form. And if you want opening up or down, you have to place the point, and then you can just move it. So what would be the center? It would be 0, 3, right? Because the X is being shift 0, and the Y is being shift a positive 3. So, well, sorry, shift 3. If Y equals 3, it would be 0. So I come in here and put 0, 3. So 0, 3. I need to zoom in, depending on the units. 2, 3. Right? There might be a way to zoom in this. No, not too bad. And then what would be my vertex? How many units do I need to go up or down from my center on the y-axis? Oh yeah, 4, sorry. So here I'm at 3. I'm at y equals 3, right? X is 0, and I need to go up 4 units. So I need to go up 7. And I place that point, right? And this is the rectangle. How many units do I go to the left or the right? 3, right? So 1, oh, that's 2, 3. Be very careful on your unit of measurements down here, because sometimes a tick marks 1, sometimes a tick marks a half. Sometimes it's 5, I don't know. So you have to be a little careful there. So I placed those points and I got my graph, and I should be able to go to my next question. Yeah, I was just graphing it. So a lot of students, practice on Alex a lot, and they will never practice on paper, and they get to the exam, and there's just that disconnect. Like, I don't have this shape. How can I even begin? So you want to practice doing that on paper too. And you don't. No, you just have to get your points. And I will say, what is the vertex? What is the center? What is the focus points? Yeah, your graph doesn't even have to look pretty, but it's very helpful to see it. What about this example? What do I need to do to graph it? in standard form, right? And this one's pretty simple because I don't have to complete the square here. I need to put it in standard form. So I might take my snippet tool here, go to, in your case, you just write it down on a piece of paper. What do I need to do to get this in standard form? Good. So what would I have? Yeah, so if I wanted to just go one step further, I could write this as 3 squared, 4 squared equals 1. I don't have to, but yeah, probably shouldn't. Because this tells you A and B, but I could also just know it's the square root of it. So now graphing this, what's my transverse axis? X, right? What's my center? So I come here, I'm going to graph this. Transverse axis is the x-axis. I graph it at 0, 0, and I go how many units on the x-axis? 3, and how many units on the y? You said it. 6, yeah. Sorry. So then if I go 3 here, be careful with my units of measurement, and 6, get the graph. And if I want to know the equation of the asymptote, y equals, what would it be? What's rise over run? 6 over 3, which is 2, or minus 6 over 3. So y equals, yeah, 2x or minus 2x. I don't know. Yeah. They have them. They're called smart boards. I don't know if you guys had much experience with it, but they're kind of fun, right? Here's an example of graphing by completing the square. So the first thing you have to do is jump in here and complete the square. So, oops. We don't need it tiny. So working on complete the square, what is our transverse axis going to be? Can you guys see from just looking? The y, right? Because the x squared term has a negative in front of it, so transverse axis is going to be the y. So I want to pull out a minus 9. I have x squared be careful with the here. If I pull out a minus 9 here, it's going to be minus 6x, right? Here I pull out a positive 25. I have a y squared minus 4y equals 206, right? What do I need to add in here to make it a perfect square? Minus 6 over 2, so it's going to be minus 3 squared. So I add 9, but I'm really adding what? I'm really adding a negative 81. So if I add a negative on the left-hand side, I have to add a negative on the right-hand side. You guys see that? Here, what am I adding? Plus 4, right? But I'm really adding 100. So what does this perfect square become? X minus 3 quantity squared, right? And what about this perfect square? Y minus 2 quantity squared. And then 206 minus 81 plus 100? 225. So dividing through by 225, I get x minus 3 quantity squared over 25, y minus 2 quantity squared over 9 equals 1. So that tells me my transverse axis is the y-axis. I'm moving up and down. from my center, what's my center? 3, 2. From my center 3, 2, I move up 3 units and down 3 units, and the left 5 units and the right 5 units, right? If I can remember all that. We say 3, 2. Positive 3, 2. Transverse axis was the y-axis, and I moved how many units? 3. So 5, right? She would tell me this is 2, 3. Oh, so each unit here, each tick marks 1 here, so it makes it a little easier than the half tick marks. And then I go over 5, and it graphs it. Just reassuring. I go the y-axis 3, the x-axis 5. You guys see that? And next question is find the F1 and F2 of the hyperbola. So we're looking for the focus point. So that's the C value, right? So we have to complete the square, find the C, and C squared is A squared plus B squared. And then I have to find, is it opening in the X or opening in the Y? And then I have to go C units to the left or right if it's opening in the X, if it's C units up and down on my Y, if it's opening up or down. So completing the square. Oops. You guys see that it's opening left or right? Right? So for my center, my Y components are not changing. Only my X is changing. So my Y components here will whatever be the shift in the Y will be what you have to complete the square in. So factoring out a 25 from my X terms, what am I left with? Minus 6X. Factoring out a minus 16. Be very careful because the negative's here. 128 divided by 16. 8. $431. What do I need to add in here? Minus 6 over 2 quantity squared, minus 3 quantity squared. So I'm adding 9, but I'm really adding 9 times 25. Which would be 225. Then I'm adding 8 over 2 squared, which is 4 squared, which is 16. But I'm really adding minus 16 times 16. We get 256. Yeah. To what? Oh. 256. So breaking this down, 25 x minus 3 quantity squared minus 16 y plus 4 quantity squared equals, what is it? 400. Dividing by 400, we get x minus 3 quantity squared over 16 minus y plus 4 quantity squared over 25 equals 1. So in this case, we said it's opening to the left to the right. The center is 3, 4. 3 minus 4, right? So all these points are going to be minus 4. right, for the y component. So whatever I open here, I don't care in this case what my vertex is, I only care what my focus points are. This is C units. So here A is 5 and B is 4, right? So I define C. C squared is A squared plus B squared. C squared is 25 plus 16. So C would be 41. C squared is 41. So C is the square root of 41. So if I go from 3 and I add a square root of 41, I have 3 plus the square root of 41, comma, minus 4. You see that? And this would be 3 minus the square root of 41, comma, minus 4. The minus 4s don't change because I'm opening x on the x. The transverse axis is my y-axis, or parallel to my y-axis. And this is just the number. You should be able to plug it in like that. It's always fun to test it. So we have 3 plus, what did I say, 41, comma, minus 4, and 3 minus, comma, minus 4. Oops. You see that? Here's the example of taking information from the graph and coming up with a function or equation. So you can kind of, set up, I have x plus or minus something, right, over something plus or minus, depending on y minus something, y minus something. And then this is going to be squared, and this is going to be squared. So this is just kind of an outline, but we'll go through and do this problem. So we know the vertices and the focus points. So if I just kind of graph this out real quick, 8, minus 1, and 10 and minus 1. So vertices like this tells me my transverse axis is the x-axis. It's opening left and right, right? So can you see my center? Pretty easy from the graph, maybe. The center is right here, which is 9, comma, minus 1. What is the A value? 1, right? So this would be A equals 1. A being the number under the X. So then it doesn't give us B. It does give us the C point, which is at 7 minus 1. 1, 2, 3, 4, 5, 6, 7. So what's the C value? 2, right? So I have to calculate B, knowing C squared is A squared plus B squared. 2 squared is 1 squared plus B squared. So 4 minus 1 equals B squared. So B is the square root of 3, right? The center is at 9, comma, minus 1. Which one is the negative? The y, right? The y is the negative term. So here I would have x minus 9, quantity squared, over 1 squared minus y plus 1, quantity squared, over 3, right? Square root of 3 squared equals 1. So x minus 9. Turns out the y term was negative, and it was y plus 1. Then under the 9 was a 1. You could leave it there, or you could keep it. It doesn't. You could get rid of it. It doesn't matter. Alex should take both ways. Go ahead. 1 squared. No. Question? Wouldn't it? It is the square root of 3 squared, right? Remember A and B? Yeah. Because the distance C is 3, but it's C squared when you put it in the formula. Or, wait, did I say that right? Oh, no, I didn't say that right. B is the square root of 3. Yeah, B is the square root of 3. We found that by taking C squared equals A squared plus B squared. A is 1, so when we plug in the formula, it's A squared. B is the square root of 3 when we plug in the formula, square root of 3 squared. Right. Did it plug that in right? Right, so we can cross our fingers and hope it's all green. And it is. Yay. It's always kind of like, oh God, what did I do wrong? Like that one time I put square root of 2 and it's supposed to be 2, or 2 squared and I just put 2. So hopefully that kind of shows you what Alex's problems are. There is a little disconnect, like I said, from the graphing. So it seems easy on Alex, right? Oh, I put my center, I go this way, then boom. So expect it, to take some time on the, if I give you a blank piece of paper and say, graph this, find the focus points, find the vertices, find the equation of the asymptote, you can go about and do that. Any questions on 7.2? We will start 7.3. 7.3 even assigned? Where's 7.3 at? On Alex? Oh, I'm on results. Okay, because I haven't taken it yet. 7.3. Yeah, I don't think there is one. It doesn't need to know. I'm just kidding. Keep our fingers crossed. We will start 7.3, which is the parabola. So along the same lines, you guys have seen parabolas before, probably. You've seen y equals x squared, which is the basic parabola. We started with that, and then we shift it right or left. We're going to do the same thing, except we're going to have, it could open in the x-axis, it could open in the y-axis, or it could open in the x-axis. So we could have x equals y squared. And then we're going to have the vertex, we're going to have a focus point, and we're going to have a dextrous. And then we're going to shift that all in space and do the exact same things we've been doing. All right, I will see you guys on Friday.